well. This is from the IPCC report, and because we're going to confine our remarks to just a few minutes, look at the right-hand column, the three reddish and orange maps of the world on the right. The top picture, the top right figure, is warming. The darker the red, the greater the warming, in the last decade of the present century, the decade of the 2090s, as predicted by a number of computer simulations and assessed by the IPCC. And you can see that the continents have warmed, the Arctic is warmed more than other parts, the oceans have warmed too, but the middle picture is one with a slightly higher amount of carbon dioxide and the other greenhouse gases. And the bottom one is business as usual, that is, a continued reliance on fossil fuels, now providing 80% of global energy, which produce carbon dioxide, and a continuing growth in population. The bottom right figure is, you might say, the default. It's what happens if no action is taken, if mankind continues in the present century as it has for the past 2 centuries. Then you get a different planet. That bottom right figure is one in which all the seasonal sea ice in the Arctic is gone, all the continents have warmed drastically, the oceans have continued to warm and to acidify because carbon dioxide makes the oceans more acid. And in that bottom right figure, that's what happens if we don't do anything. That's what happens if simply we continue on our present path. I want to say a word about how good the IPCC projections are. This is a figure from a scientific paper published a year ago. At the top, you can see carbon dioxide continuing to rise. At the middle, temperature rising. And at the bottom, sea level rising. And we, the authors of this paper, concluded that the previous projections of the IPCC had not exaggerated the future course. These are projections dating back 20 years to the beginning of the IPCC. But instead, in the case of sea level at least, they have, if anything, underestimated sea level. All the changes since the IPCC report, all the major changes, the IPCC report was published last year, but it's really based on science that's about 3 years old at the best. And the science that's come in since, the observations that have been made since that time, have all shown upward trends in these kinds of factors. CO2, carbon dioxide, is now growing faster than it was before. China has passed the United States as the largest emitter of CO2. More and more parts of the world are industrializing on fossil fuels and producing CO2. China is opening a new coal-fired power plant about once a week. The temperature is rising too. The ups and downs in the middle picture are El Niños, but the overall trend, the smooth, heavy red and blue lines from 2 different data sets, show continued rise. And sea level is rising near the top of the IPCC projection. So if anything, the IPCC, which is not political, but which is intellectually conservative, which doesn't go beyond the data, where scientists hesitate to speculate and conjecture, the IPCC has been conservative, you might say. The state of the science hasn't kept up with as fast as we're changing nature. I'm going to pass this over, but this is an exaggeration and a bit blown up effect of the temperature curve. You can see the effects of these big El Niños. The rises and falls are El Niños and La Niñas. There was a big one in 1998. People who say global warming stopped in 1998 are just intentionally misinterpreting this data. Right after the El Niño, the warming continued. I'm going to conclude by saying a word about Charles David Keeling, who's responsible for this graph of rising carbon dioxide in the atmosphere. It's quite extraordinary that one person had the idea to measure carbon dioxide in the atmosphere accurately, designed and built the instrument, carried on the measurements himself. Dave Keeling died 3 years ago. The measurements are now being carried on by others. But he spent his life struggling to make it possible to continue the measurements, getting the funding to do it. The measurements are made, the first set, most important set, at Mauna Loa, an island a volcano on an island in Hawaii. You can see the observatory there. The data are still being taken, and as I said, there's no argument about these data. In fact, to a physicist, global warming is pretty simple. You add carbon dioxide, it makes the atmosphere less transparent to infrared radiation. It puts the greenhouse effect, the blanket that keeps us naturally warm, in human hands. As I said, more than 1 out of 4 molecules of carbon dioxide in the atmosphere today is there because we, all of us, all 6.5 billion of us and our friends, have been putting it there and are continuing to put it there. Keeling almost lost funding, kept struggling to get the money to maintain this rather inexpensive record. Today, this is the Great Hall of the National Academy of Sciences of the United States in Washington. On the right, you can see some of the iconic totems of modern science, the double helix from DNA, Mendel's peas, in the center, Darwin's finches, and on the left, above the bridge, Dave Keeling's curve of carbon dioxide. I said I would close with a word about policy and about solutions. The solution to the global warming issue is to drastically reduce the amount of carbon dioxide that we emit into the atmosphere. And there won't be a magic single solution for that. It will require huge efforts internationally on the part of governments, people, localities, individuals, corporations, to reduce our dependence on fossil fuels, not by 1 or 2 or 5%, but by 50 or 70 or 80% over coming decades. That can be accomplished by energy conservation, by energy efficiency, by switching to renewables, by working hard on new sources of energy. There's a lot that can be done. It will require popular will and political courage throughout the world to do it. But the IPCC, speaking for science, shows very clearly what happens if you don't do it. You get to a planet that you don't want to see. Thank you.
Two quick points there. I noticed in the New York Times this morning that there's a huge story in there about China and its budget problems because nobody's importing anything from China anymore. So it's as well to remember how quickly things change and what effect that'll have on their emissions. I have no idea. But second thing is that the point you made about Dave Keeling, it exemplifies one of the points we were making this morning about how powerful some outlying scientists the kind of results that they can have. And there's sort of a moral there for the younger folks in the audience, isn't there?
Yes, I think there is a moral there. I don't think that any decrease in China's emissions is going to be more than temporary. And I think that Dave Keeling is an inspiration to young people, especially to young people who might want to be scientists. He argued with his boss, he argued with his colleagues, he argued with the funding agencies that supported his research, and in the end, he was absolutely right. The world owes him a great debt.